In this video, I'm going to show you how to evaluate functions of more than one variable given in standard notation. So here we're given the function f of xy is 5x minus 3y. And this is a function of more than one variable. We've got two inputs into this function. There's an input x and an input y, and both of these inputs are used in the definition of the function. So the function takes these two inputs and gives a single output which depends on these two inputs. Okay. So we're given this function and we want to compute these two values of the function. The first value has actual numbers 1 and 2 for the inputs x and y, and the second value here has both inputs x and y in terms of another variable p. But if that looks scary, don't worry about it yet. We'll just tackle this first one and then that'll give us a really good idea on how to proceed with the second one. Okay, so the first one, f of 1, 2. So we want to compute f of 1, 2 using the function definition, which is function of xy is 5x minus 3y. So the inputs 1, 2 just correspond to the inputs x and y. 1 corresponds to x and 2 corresponds to y. And we just plug it in like we would with any other single variable function, except now we've got two variables that we're plugging in for. So 1 goes where x was in the original function expression. So we've got 5 times 1, and then minus 3 times y gets replaced with 2. So minus 3 times 2, and then we just compute that. So that's equal to 5 minus 6, which comes out to negative 1. So there we go. That is the value of f of 1, 2. Okay, now f of p minus 1. This is really just the same idea. P is going to get plugged in for x, and p minus 1 is going to get plugged in for y, and then we'll just evaluate. So let's go ahead and do this. 5 times x becomes p, and then minus 3 times y, and y becomes p minus 1. And then we just compute, and we get 5p minus, we'll distribute this, so minus 3p, and then negative 3 times negative 1 is positive 3, so plus 3. And then we go ahead and simplify 5p minus 3p, that's just 2p. And then plus 3, and there we go. That's our result. That's f of p minus 1. An interesting thing to point out here is that f has two inputs, x and y, but when we express x and y in terms of a single input, p, then f just becomes like a single variable function. X and y are both expressed in terms of p here, and then the final output just depends on p. Alright, here's a second example here, and this example probably looks a lot scarier. We've got this huge expression here, but it's really not so bad, as we'll see. So we're given these functions, f of x and y is 5x minus 3y, that's the same function as before. And we also have another function, which is now a function that accepts three inputs, x, y, and z. So the function g of these three inputs, x, y, and z, is just x plus y, the quantity squared, minus yz. And we want to compute this f of the two inputs. One of them is g of 1, 1, 0, and the other one is g of 0, 1, 1. Okay, so our first task here, let's simplify this. Let's go ahead and evaluate what these g functions are. So first of all, what is g of 1, 1, 0? Well, in order to find g of 1, 1, 0, we just plug in 1 for x, 1 for y, and 0 for z. So let's go ahead and do this. So 1 for x, so 1 goes in there for x, and then plus 1 for y, and then that's squared, and then minus y times z. So minus y is 1, and then z is 0. So minus 1 times 0, and that just comes out to, well, 1 plus 1, that's 2, then squared, minus 1 times 0 is 0, so just 2 squared is 4, and then minus 0, so still just 4. Okay, so this is 4, that first input is 4, and then the second input is g of 0, 1, 1. And what is that? Well, we'll just do the same thing, sub in 0 for x, 1 for y, and 1 for z. So let's do that. 0 for x, so we've got 0, then plus 1 for y, 0 plus 1 squared, minus y times z. Y and z are both 1, so minus 1 times 1. Okay, so this is 0 plus 1 is just 1. Square that and subtract 1 times 1 is 1. Okay, so this is just 1 minus 1, which is 0. Okay, cool. So now we know the actual inputs to f. We've solved for what they are. We plugged them into g, figured out what it comes out to. So what we really have to evaluate is f of these two inputs. The two inputs that we found were 4 for the first input here, so 4, and then the other one was 0. So f of 4 is 0. And we can just compute that by plugging 4 and 0 into the expression for f here. So 4 goes in for x, so this is 5 times 4, and then minus 3 times y, in this case y is 0. Okay, and then we do that, and 5 times 4 is 20, and then minus 3 times 0 is 0, so just 20 minus 0, and that's just 20. And there we go, that's our final result. That's what this big expression is equal to. So now that we're starting to get more comfortable doing complicated operations with functions, we'll also learn how to become more abstract and represent functions using non-standard notation in the future.